All right. Thank you everyone for joining. After the end of this session, I will be uploading this recording to learning.udemy.com, where you can find all our other wonderful Tech Talk recordings. If you're interested in leading a future session, please slap me. So do you love GraphQL? Do you know how to create a good API service? Have you ever run into performance issues caused by nested queries? If any of the above apply to you, you are in the right place. Detective Jono is here to share his investigation of the n+1 problem and solutions that are currently in use at Udemy. There are a lot of information that is being shared today, so please hold your questions to the end. With that, Detective Jono, please take it away.
All right, thank you. That was a cool intro. Let's see if I can share my screen correctly. Yes. All right, thanks, Sam, for making this cool graphic here. I'm going to start my slides here. Okay. Hi, everybody. My name is Jono. I work on the Measure Competence team, specifically mostly on the adaptive assessments program, and been here for a little while and spent a lot of time on GraphQL. So I have quite a few slides, and I do want to answer your questions because there's a lot of information here, but it's probably best to hold them to the end so we can get through all the slides. Yeah. Okay. I think that's everything. Also, I'm not very visual, so my slides are a little bit of a mess, but I tried my best. Let's see. And I'm going to try, I just found out about this drawing thing. How can I do it? Spotlight. Vanishing pen. That's cool. Check out this thing I just found out about. Okay. Except it won't let me change. Oh well. Okay. All right. So I guess I'm going to assume most of you guys know a bit about GraphQL and about gRPC because I'm going to be talking about those things, and less so about gRPC. But GraphQL is awesome. When I say consumers love GraphQL, I'm talking about people who consume GraphQL. In our case, that's React for the most part. It's very nice because you can construct a very nice query that gives you back exactly what you need. You don't have to go to the database for a whole bunch of separate things and push them together for your need. You can kind of do it's a very self-service API system. So it's great for the consumer, but we're going to talk about what it is to create that server. Some other cool stuff about GraphQL is as a type system, so you could do strong typing stuff with it, very powerful. And I'm not going to get into that topic too much. Okay, so here's an example of what a query and a response looks like. We have query on the left. So you ask here, here's a course. I want to get all the reviews for the course. This isn't exactly what our system looks like. I'm just kind of making it look something like Udemy like stuff. You have a course, you want to get all the information, you want to get a bunch of information out of the course. We have reviews, we have users, we have the name of the user. Can I get this thing back? Yeah. Okay, so let's look at let's say we're coming from a RESTful place first before we go to the GraphQL, see what things used to look like. This is not a great implementation of it, but here's what like a naive REST system might look like. Here, let's say we're on a page where we're showing some course info and we want to show the reviews for it. Let's take it. Here's our REST request. We come in, we say, okay, get me information about this course. You know, it just has like the name of the course. Then I want to know the reviews. So this is going to say like the content of each review. And then we fetch things about the user because you probably want to say something about the user, like put their name or email address or something on that page. So we'll make an additional trip to the database to find the data specific to those users. So you can see right here, if we have 3 reviews, we're gonna make 3 trips to get information about each user. Courses might be 1 trip, and the get the reviews is one trip. All right, so that's like a naive implementation. Now let's say we're moving into a GraphQL world where we're going to fetch the same sort of data. We'll make a single query, and we have this middleman GraphQL server, which is the part that we are implementing, and it's going to farm out these requests to our sub-services. And so now we're not leaving it to React or the front end to figure out how to optimize and make good network requests. We're kind of taking it in our control, and we can do very cool stuff with it once we have it in our hands. I want to talk a little bit about GraphQL resolvers. Each level of this, well, every item here has a resolver, technically speaking. Every one of these is a node. A course is a node, a title is a node, or a view, text, stars. But these ones at the bottom, these are, I think they call them terminal nodes. I'm not exactly sure what the word is for them, but all these red ones are terminal nodes. It means they're resolved to themselves. They don't have any children. So generally speaking, when we're going to figure out this query in GraphQL, we're going to start by figuring out the course, go fetch the course data. We have these terminal nodes, so we don't need to fetch anything below that. But you do need, this is another root node. So we're going to have to go fetch the thing below that, and we're going to have to fetch things below that. So resolvers kind of go down a tree, and we use resolvers are a deep concept in GraphQL, so you definitely need to know about it. I'll talk about it a little more. Okay, so implementing a good GraphQL API is not trivial. It's nice to optimize it. Actually, it's very important. You really need to optimize it because you can very easily step on your foot. Okay, I'm going to talk about the n+1 problem. Maybe some of you have heard of the n+1 problem. It's not specific to GraphQL, but it's very visible in GraphQL. So I'm going to dive into it here. Generally speaking, an n+1 problem is when you make too many requests. So in the bad world, when your number of requests inflate with the size of your data set. So in this example, if we have a lot of users, we're going to make a lot of requests. If we have 100 reviews, we want to fetch information about each user, we're going to have to make 100 requests. That right there is an n+1 problem. So we don't want the number of requests to inflate with the size of the data set, because the amount of reviews you have shouldn't actually make you make more requests. It might make the query take longer to execute, but we don't have to make more network requests for it. So, and to solve this n+1 problem, we want to make the fewest number of requests. Generally, you would like to, regardless of the query, always make roughly the same amount of requests. Yeah. All right, so I just kind of talked about this a little bit. We have the GraphQL server here, and it's going to farm out these network requests. And here's the n+1. Because we have a lot of reviews, we need to get information about each user. So we can very easily do something called batching, which may have been obvious in the first place. You could have done it in REST, but the cool thing is here, we can solve this at the GraphQL level. We don't need the person issuing the query to have to think of this. So instead of getting users one by one, we want to go get a list of users. Very simple. That solves the n+1 problem in the most general way. Let's talk a little bit more about that. Yes, I'm going to talk about some anti-patterns before we go there. Now, in a REST world, sometimes you might, let's say you have a course service and you want to get, we could create a single endpoint that says get course reviews, because we know in this case, this page wants the course and the reviews. And then that means you can make one trip, get everything you need. Maybe, and that can have all the user data. The problem is you're kind of defined. Next time we say get course with reviews and with ratings or something, right? So, or sorry, get reviews and pictures or something. You need some more data. So we're gonna have to create a new API endpoint for that. We don't want to do that. That's API sprawl. That's where the API developer is creating all these special case endpoints. So we don't want to do that. Also, on the overfetching side, if we do this get course with reviews, often it means you're pulling all the data from a user, for example, but maybe a user itself has 50 fields, but we only really need these 2 fields. You want to optimize that as well. So that's something we can do with GraphQL. Just fetch the stuff we need. Okay, let's look at how these resolver relationships work. So in practice, here's what the requests are going to look like that come out of the GraphQL server. First, want to get the course object, which is a single request. And that's just going to fetch us this node. It's going to fetch us the content. And then we want to get the review IDs. So we're also going to do this, which is going to fetch this list of reviews. That's a separate request. They're not the same request. I'll get more into that in a little bit. Then we make an additional request to actually get the content that lives in those reviews. In this case, it's the stars. So we have this result 147. We say get review objects. This is an example of batching instead of doing them one by one. And we get the stars. And then we also get the user IDs. This is important because we don't actually know that the person who's issuing this query wants the user content. When you get to this point in the resolver, you just know that they get the reviews. It's up to the user resolver to determine if you need more information about the user. So now that we have this ID in memory, we can later, if the user asks for a name and photo, we can say, okay, go get the user objects that belong to those IDs. And we can get the content, names and photos. Okay, so I want to point out something about the relationships. Here we have a one-to-many, so we're saying this course has many reviews. So we have a single item returning a list, and we have these one-to-ones, which I just talked about. We're like here, a review has a one user, so we still have relationships, but here we're just returning the ID, not the content. Okay, now let's go a little deeper. So the trick is here we're getting all the courses. See, the previous one we're giving a single item. Now we're getting all the courses. I don't know why you would make such a query, but if your server allows this, here you go. So now in this case, we have some additional things to look at. When you get course objects, you're starting with, you're getting a list. So I say, give me all the courses, give me a list. Now I can't just get the reviews for that single list. I have to get the reviews for each item in that list. So in this case, it's a many-to-many. I'm going to give it the ID that belongs to the course object to each one. And it's going to return me this list of lists. So 20 corresponds to, let's see, review 20 has users 147. Review 21 has users 8 and 9. I said that wrong. But anyway, these are the reviews. Yeah. Okay, now we get, so that's a many-to-many. And now you can see this batching is getting a little more complicated because we have lists of lists. But don't worry, you shouldn't need to it shouldn't need to get any more complicated than that. Okay, so now we have this interesting thing where we have this list of lists, but we need to unpack them and get them all at once. Because why you don't want to make a request for this batch and this batch, then you already have an n+1. So we're going to fetch all of them at once. And we're going to see the content and the user IDs. And now, just like before, we get the user objects. But the interesting thing here is caching. So I'm going to explain what's happening here. You see we have some redundant user IDs here, right? We have 100, we have 102 and 102, and we have 100 and 100. That we don't want to go fetch those twice. So it's a weird use of the word caching, but this is what we call caching in the GraphQL world, where the idea is you're going to fetch just what you need, and they're cached in memory, kind of. So you don't have to go fetch. Next time I need ID 100, maybe in a whole separate part of this query for some reason, I already have it in memory, so I don't need to go fetch it again. Cool. Okay, you go even deeper. Courses have reviews. Reviews have users. Users have reviews. Reviews have users. You could keep going and going and going. Oh boy, that gets crazy. I hope you don't have to deal with that. But look, you're writing a GraphQL server. You can have users that are going to do stuff like this. Maybe they're not trying to mess you up, but people can make these queries, and that's problematic. Okay, so to deal with this, I would say definitely use caching, because like I was saying with memory, let's say this goes real deep, reviews, users, reviews. After a while, what's going to happen is you're going to have the same users and the same reviews going back and forth. So you're not going to need to go refetch the same user again. So when you get really deep here, you're actually going to have everything you need in memory probably. And you won't need to go fetch more users from the service. That's why caching is great. Also, you should limit the depth while you're at it. I mentioned that because do you want your user to be able to do this? I mean, if your server is not implemented well and you're not doing caching or anything, I've seen it where it really can hammer your server and take stuff down, take things down for other people as well. At the end of this talk, I have a link to a talk about security, OWASP vulnerabilities specific to GraphQL, and this is a top thing that people attack. They try to do very deep queries. So we can limit it on the server side if we want. All right, so the takeaway here is when you are creating your microservice that's going to serve content to GraphQL, you should design your endpoints to receive data and send it back in a certain way. So here we have these, you allow it to receive a list of IDs and return a list of objects. And also you should have relationship fetchers. So this is where you actually, essentially this is a foreign key. This is the one-to-many map. So we create different endpoints that allow you just to get the maps without the content. Okay, now I've talked about batching and caching. I'll tell you about data loaders. Data loaders is kind of the way of doing this. It's already implemented. It's a common pattern. It's been around before GraphQL to deal with the n+1 problem. And whenever you're working on a GraphQL server, there are libraries that will do it for you, but you need to implement it correctly. So what I mean is you need to basically follow these guidelines that I just said, and you could use it correctly. You don't need to implement caching. It's going to store those users in its own area, so it can fetch it out again later. All right, so going back, just repeating this again, because these are very important concepts. Caching prevents the same data from being fetched twice in the query. If you already have a user, don't go again. Batching, which is even more important, is grouping or fetches into fewer requests. That's the big n+1 killer there. Okay, so a little more details about when you're implementing these endpoints. When you fetch an object, in these examples where you're giving it a list of IDs and you need a list of, here we give it a list of IDs and then you need a list of objects, you actually need to be sensitive about how you send these objects back. So let's say your service is just doing a select in. So we have these IDs and it just wants to select these things, but maybe some of these IDs aren't present in the database. Well, your MySQL is going to actually come back with only 3. And the data loader is actually expecting you to come back with 5 because it wants kind of a one-to-one mapping of these. So we have to make them nullable. So in a good implementation, you actually return these null gaps. So it comes back and it says, oh, I know that I asked for ID 20 and there is no 20. So it can hold on to the cache. Also, you need to preserve the order because, like I said, it's very one-to-one. It knows ID 1 is going to correspond to this one. ID 2 is going to correspond to this one. Yeah, they're parallel arrays. Oh, and I'll say, I couldn't find a way to do this in SQL itself, to put these gaps in and the ordering and all that stuff. For me, I had to do it in code. For us, this is Python code. Maybe there are nice ways of doing this. It's fairly easy, but it's something that I had to implement and know that you need it. Yeah. Okay, here's another thing about tuning your data loader. You can go when there are times when you need to fetch many IDs. You might need to fetch thousands of IDs worth of objects. So out of the box, when you're using your service, you could give it any number of IDs. That itself could be some sort of attack, where someone could try to, I mean, they don't know exactly how it's implemented, but they could try to send, get something very big, send it to your service. So that means it's gonna get a lot of input and get a lot of output. And you can do paging and stuff to bring down the output. But the important thing is you don't want those actual requests going to the server to be too big. And we run into those problems here at Udemy. I know talked with some DSI folks about limiting the size of IDs in some contexts. And they're talking about more about like amount of kilobytes or something like that. But we can actually, as an optimization, we can say only fetch 100 at a time. Now, let's say your query itself needs 2,000 IDs. So data loader itself will transparently make requests in batches of 100. So you're not overloading your service. That's good to know. But it does reintroduce the n+1 problem. It's a little bit more manageable, but now you have this, you're taking this 2,000, you're splitting it into 20 requests. So that's scaling with your data set. So be careful with it. I would say set the number pretty high. You shouldn't need to do, when you're running the queries that need batches like that, you might want to see why it needs so many. But it is good to set a limit on it and hope you never reach it. Okay, so data loaders are not a silver bullet. They'll get you pretty far, and they're highly recommended, and they've really taken off since GraphQL has taken off. And they work well with the architecture we use, but they're not always the best, or they're not always the solution. Let me show you a good way. You can still be using data loaders, but I'm saying it's not a silver bullet. I'm saying here you can use it unwisely and still step on your foot. Okay, so let's look at this query where you're getting a course and a title and a student, and then they have a SNORF rank. That's just a made up number. I'm saying, it's a rank of a student, how good they are at the course or something. So let's see this implementation. First, you're doing this select ID in there. That's good. They're doing an inquiry, so that's a batch query. That's good. Now you have all the students. You want to get a one-to-many. This is good. One-to-many is good. You're getting a whole list. Now you're doing for each student, do some sort of calculation where you're going to go make another request across the network. And that request is going to go make a request to the database. Right here, this for each is essentially introducing an n+1 problem. So there are times when this is unavoidable, but when you design it, it's always best to return lists. So a better way to do this would be, create an endpoint where you get all the names, but you also can get all the SNORF ranks. You want to get a list of ranks instead of doing these one-off calculations. You'll see these things in code a lot. The problem is it's very easy to implement this way, right? And you won't necessarily see the performance degrade if you have a small data set, but over time you might see things hurting. I've been at places where we don't notice these n+1s until our data set gets really big, and all of a sudden these queries are taking a long time, the logs are exploding, so you have to deal with it at the last minute. Yeah, I try to think of these things, they're a little bit like a memory leak. Like they're not going to stop it from going, but at some point they will cause problems. Yeah. All right, so I'm working on the adaptive assessments service. On my team, I'm going to show you kind of how we implemented some of these things for our team. Okay, this is what I implemented based on my research. Okay, so here's before and after. Before, we used to use an adaptive assessments. We used to use something called graphene. Graphene was basically a GraphQL server that lived inside Python, inside Django. So Python knew all about the resolvers. It knew how to break apart queries, how to deal n+1s a little bit. But we're moving to a new world where we want at Udemy, we're trying to not have each service know about GraphQL. The idea is we have one giant GraphQL service, sort of a GraphQL gateway, and you would ask it any questions you want, and all the GraphQL logic lives in that service. And then your subservice, in my case, it's our adaptive assessments, we serve out gRPC. So we're just going to say, we have an endpoint where you can talk over RPC and just get a bunch of testlets, get a bunch of questions. RPC is great because we can use it very quickly. It's inside our network. It's optimized for speed and security. But what this means is the people on my team, adaptive assessments, we think more about the gRPC, just what kind of things do people need, where the GraphQL logic all lives in this shared server. One thing I'll say is we are using GraphQL server now, which we call federation, and it's sort of confusing because we use it in two ways. We use it for federation and we use it for its own resolvers. When you hear someone say something about federation, they mean roughly what they're doing is they're just taking this query and handing it right across. They're proxying it right into adaptive assessments. And adaptive assessments is dealing with all the GraphQL. So here, Apollo is not really doing a lot. It's kind of aggregating a bunch of services, but it's not actually implementing the GraphQL. It's just proxying requests. Now, in the new world, we implement all of the GraphQL here. So it actually, we have to take all this resolver logic and move it in here. Okay, so looking a little bit at this query, this before query, we came in with this full query and it gets all the way to inside adaptive assessments where the resolvers span out all the requests it needs to the database. Where now in the new world, it's different. The resolvers happen very early in the process and we make these requests early on. So here we have the testlet, which just, remember, oh yeah, this is a little bit different than my previous example, but here's a terminal node we just created. We do a fetch for a question, where a question will give you all the IDs. And then we actually have the question. Oh, this is the 1 to 90. And this is the one where we actually fetch the objects. Cool. All right, so going over that again, before our team, the adaptive assessments, it was all Python. All Graphene was Python. And we didn't need to know anything about federation. Federation just proxied. Now the Apollo service does a GraphQL and it handles the query resolvers. This is important because someone has to implement these resolvers in Node, right? So we've changed stacks here. So we're taking those Python resolvers from Graphene and we're re-implementing them in Node. Yeah. Now, in our case, we developed, like our team is responsible for the GraphQL resolvers here. It doesn't have to be the case. There could be a case where you have like a GraphQL API group that just deals with all those, deals with all this stuff, and we just give them this to consume. Okay, so something to note that's important. Before we were joining in SQL. So we were actually, when we needed all this data, we could just fetch, the resolver allowed us to actually do this 1 mega SQL query and get everything we needed. We were doing this join query. Now we can't really do the join query anymore because the joins are actually happening in the GraphQL server. So we actually have to make these separate requests, right? So you don't see any joins anymore. The joins are happening in Node. So we're familiar with these already. You fetch the course ID, or you fetch a bunch of data with the course ID, you get a bunch of data from the reviews and from the users, right? These are batching because we have these in queries, but we're still making 3 separate queries. Not ideal, but it's a price to pay. So remember, the pro of this new system is all your GraphQL lives in one place. And the con is that we're making more requests to the database. like I just showed you. So make every request count and always be batching. Try to batch your things as much as possible. Use a data loader because the trips to the database become more critical. All right, so it is likely that people have n+1s. It's easier to have them than to not, just like a memory leak. So how can we find them? There's a couple ways that I thought of just when I was quickly making the slide. In code, you can have helper functions that make database calls for each entity. This is exactly what I was talking. Let's see. Yeah, this is very simply, look in your code to see if you have any select where ID equals, like this example here. That could be a red flag in your code because typically we want to do in. So you can look for it in your code. You can also look for where a single item is fetched instead of a list or aggregate. Similar idea. In log SQL queries, so let's say you don't have control over the query, you're just looking at the logs and you want to see, you can get verbose SQL output in Datadog, and you can just see, wow, one GraphQL query happened and it made 100 SQL queries. That seems like a lot. Okay, so that could be a red flag. So you can compare query counts between data sets of different sizes. Yes, remember the n+1 means that size matters. And again, we're looking for inquiries. We don't want these equals queries. Okay, and I was just talking about Datadog. I love this flame graph that's in Datadog. I don't exactly know how this tracing stuff works, but it's amazing. Right here we come in through GraphQL and we see a whole bunch of requests going on. Then it comes all the way down to gRPC. So it's making these gRPC requests. This is a request from some server, presumably from the GraphQL server. Oh yeah, this GraphQL. And then here, this is actually in the adaptive assessment server. That's in the gRPC service. And now these blue ones, which I have selected here, it shows my SQL query. And you can click into this and it'll tell you what the query is. This is great. Look at this all this hammering of blue down here. There's a lot of queries going on. Maybe that's a red flag, maybe it isn't. Maybe this answer question thing needs 50 queries every time. Regardless, it's not an n+1. But this is a good thing to look out for. Now, if anybody knows, I actually don't know how to do this in Datadog, but I would love it if there's a way to actually keep an eye on these. I'd love to say, I love it to see a dashboard that said this GraphQL query made 50 requests to the database. Just have that number on the side. That'd be great, because there's not a certain number that is too many requests, but I think there's a lot of stuff you can do with heuristics that say, you usually when you make this query, usually it takes 50 requests. Today it's taking 100 requests. There's a lot of stuff like that you can do. One company I was working at did have a tool that I think sort of monitored them while you were developing. It would see, oh, this request usually takes 10 to 20, but now it's taking 100. So it would kind of do dynamic analysis. I thought was cool. I think it'd be great if we could do something like this in Datadog, because our production data is different and higher workloads. Okay, so this is pretty much the end. Keep calm and definitely work on squashing those n+1s. They are critical. And here's a couple pointers to things that we can share out when the slides go out. Here's an actual link to the code where in Federation. So this is the node code that we wrote with the resolvers. Here's our actual GraphQL service that implements the batch items. And here's a blog post I wrote last year at a GraphQL conference that did an interesting talk about GraphQL security. And I think it's just interesting to read. You could read about those crazy trees and how people do weird attacks. And actually, I think we do some of these workshops here, these security workshops. That would be a cool thing to get into some of the GraphQL side of stuff. All right, so that's it. There's a lot in there, so let me know if you have any questions that I could go back to any slides and stuff.
Go for it, Travis.
You might have said this, but is there any support for a cursor pattern? You know, you get 100 responses back, but then there's a way to request the rest. And then secondarily, what are best practices in terms of with these resolvers of ordering and filtering? You know, we've got 10-year-old user reviews on some of our courses, and maybe those aren't the first that should be shown.
Okay, good question. So let's look at one of these things. Let's look at an example query. Okay, what was it? So your first question was about a cursor. I actually don't know about anything with a cursor. I mean, I think cursor kind of implies some sort of statefulness, which this is not stateful, but where could you implement it? I think at the GraphQL level, perhaps you could implement something that's holding on to an item and pick up where it left off. Not sure. Maybe it'd actually be on your service
like
side.
I was thinking more of like a bookmark. You know, you get 100 things that are alike, and then 101st thing that's a bookmark. They're like, okay, here's where you restart the query.
Yeah, so
Restart the query.
that just depends on how you implement your GraphQL API, like how you do paging. Like two ways of doing paging are like page size, page number, and then the second way is cursor and then number of results. So that just depends on how you want to represent your paging capability inside of GraphQL, and then how that translates into calls to downstream services. So like your gRPC service could have a function that's like, you know, get reviews. The first arg is a cursor, and the second arg is like number of results. So you can do paging either way.
Okay.
Yeah, actually, paging would have been a cool thing to add to this. I will say a lot of the paging logic you could probably do on the GraphQL side, because, for example, here you get courses. You already know you have 1,000 courses. So now that you're fetching IDs, you don't need to say, give me 100 of these courses. You could say, I'm going to give you 100 of these. I'm going to ask for 100 from my backend service. So I think you could implement a lot on that side of it, where your service didn't have to know a whole lot. Okay, and your second question was about, remind me again?
Ordering and filtering, is there a best
yeah.
practice, or you just do whatever the business needs?
Yeah, I mean, you could definitely filter and order. Like, for example, this IDE is 1, 2, 3. That we can just consider a filter, but you could add all sorts of different filtering. There's different ways of what is a best practice? I've seen this implemented differently on different servers. Hasura, for example, one of my favorite GraphQL projects, they have a whole kind of, they're translating the query basically into SQL. So they actually allow these query. It looks a little bit like you have SQL conditions. So you can give it a whole list of, you know, where ID is this and reviews have more than 5 stars. You know, it's a big filtering up there. I think also in GraphQL, we don't use this in practice, but I think you can filter at sublevels. You can say, you know, like a course, for example, at this level, we don't want to put stuff about a user because we don't know that they're going to ask for stuff about a user. So we would probably want to say, get the courses, and then when we get all the way down to the user, you know, only fetch them if, what would you want for a user? What's a better example? Let's say we want to do something for reviews. Yeah, here you could filter it down for only reviews of 5 stars instead of filtering it. Are you seeing my cursor? Yeah. Instead of filtering it there, you actually do the filter here. You can put a parameter in there.
Okay, thank you.
Yeah.
Justin, do you have a question?
Nope.
Any other questions? Well, Jono, if people do have questions, is it okay for them to reach out to you Slack, or is there a specific channel?
Yeah, you can reach out to me because this is the only implementation of this if you're interested in this type of implementation, but there's also a GraphQL room in Slack where we talk about the server and ideas and stuff. And there's, you know, people in there who are well versed, and we'll talk about it too.
Awesome. Well, thank you so much, Detective Jono, for leading today's session. And thank you everyone for coming. And hopefully you guys have learned something new. I'll upload the recording and the slides to our ublearning.udemy.com, and I'll share it out to the engineering Slack channel. Thank you all.